dann würde ich vorschlagen, dann machen wir es auf Englisch, dann, falls irgendwie Fragen aufkommen. Also die Folien werden, soweit ich es verstanden habe, sind auch auf Deutsch.
Ja.
Bei Fragen einfach im Chat schreiben. Ich versuche das möglichst dann zu klären. Und ja, dann würde ich sagen, wenn ihr alle bereit seid, dann übergebe ich das Wort an Mounir. Und dann wünsche ich euch viel Spaß.
Yeah, thank you, Michael. Welcome to this seminar about web scraping with Python. About me, my name is Mounir Afifi. As Michael already explained in German, we are software developers with working with CompuSafe in the junior program. And about me, I came to Germany about 2 years and a half ago as a software developer. I have several years of experience as a software developer, particularly with Oracle databases, and I also did a lot of automation with Python for testing, web scraping, and other tasks. I would like to present to you today this topic about web scraping. So for people who have not done this before, so we'll start from scratch, and we will do this with the library BeautifulSoup. It's a popular library for scraping data from XML and HTML files. As far as the prerequisites are concerned, you should have some familiarity with HTML and also some knowledge of Python. I mean, it's better to have some knowledge of Python, but also generally, if you've programmed before, it should be possible to follow. In general, we will do a review of some of the main functionalities we'll be using, so for about 15-20 minutes, just to get familiar with those functionalities, and then we will start the practical part. So in general, we'll understand first what is web scraping, some applications of web scraping, and why specifically we want to use Python to do web scraping. And then the practical part includes, as I already said, a review of Python and the use of BeautifulSoup library in order to do the web scraping. And then at the end, we'll see what you can do after this, like how if you want to expand beyond this seminar, what you can possibly do. What is web scraping? It's a set of techniques to extract information from or data from the internet. Web, we already know, it's interconnected HTML files, and which is built on top of the internet, which is the infrastructure that allows the web to exist. And scrape, it's from the verb to scrape. The scraping is from the verb to scrape. In English, means to collect with although laboriously or with difficulty. So this is essentially what web scraping is about. It's not simply getting or gathering data from any sort of data source, but actually using certain techniques to extract data that is generally unstructured or has a lot of noise in it, and we want to only get the data that we need from this source, usually HTML files. Here we have a first example of an application of web scraping. It's for a price comparison. As you might have already used, you might have seen, for example, the websites that allow you to compare different flights or prices from a certain product. or such. These websites gather the data in different ways. One of them is through web scraping. So they have applications or scripts that go into different websites and gather the data from there and then organize it in a way that is useful for the customer. Price comparison can also be useful for business to do some benchmarking. So, for example, they want to roll out a product and want to see what is available on the market, what prices are available, and other characteristics of a product. This also can be done by web scraping. Another application of web scraping is sentiment analysis. So, for example, you want to, let's say, your business, you have a product and you want to see what, you already, let's say, rolled out your product and you want to see if the customers are satisfied or not. Now, you can, of course, do surveys and such, but another way you can do that is to scour the web and see what people are saying about your product. And, for example, forums or such. Governments can also use the same idea in order to see, for example, what people believe or think about a particular topic or such. So you can gather data from social media and so on, and organize them in such a way as to get an insight to, for example, rate if the people have a negative point of view or a positive point of view or neutral point of view, for instance. You can also generate a word cloud, as you see on the screen. It can show you basically what topics are more prominent or more or keywords are more used, for example. So the next question we have to ask is why specifically Python? Some arguments that can be used are that Python is easy to learn. It's one of the languages that has the easiest, let's say, access for beginners. So people who have never done any programming, they can easily start to write some code in Python compared to other languages like C or Java, where you might need to have some background knowledge, theoretical knowledge of computer science before you can start programming. Also, the code can be more readable because Python imposes certain constraints about how you write the code. You have to tabulate. So if you want to, for example, write a function, what's inside the function is shifted a bit, so you can see clearly what is inside the function, what is outside of it. It is very versatile. It offers many possibilities. There are lots of libraries, so more than 130,000 libraries and growing. And these libraries allow so many options, so many applications. I mean, one of the criticisms that was used against Python was that, for example, it did not have very good support for mobile applications. But recently, in the last 2-3 years, there's now some libraries that can actually allow a programmer to develop for the mobile as well. So it's a language that is growing. You can use it for lots of different things. And as I just said, it has lots of libraries that you definitely cannot learn all, but you can find most of what you need in those libraries. Particularly for web scraping, there are lots of good frameworks and libraries. Also, for if you want to use the data for analysis, preparation, visualization, there are also libraries that allow you to do that. And another selling point for Python is that it has a very big community. And essentially, if you're a beginner or intermediary or even advanced user, and you have some problem or issue, you can easily find people who will answer your questions, or you can find people who already have the same issue, and you can solve it very quickly. Yeah, so next thing is I want to give you, if for people who want to follow the practical part, if you haven't already installed Python, or you want to install the libraries that we use, BeautifulSoup in particular, you have this possibility, so that we can start properly with the practical part. Okay, so I will proceed. I'll assume that you all have the Python installed, and we will go into the practical part. So anyways, this is a link to download Python. You have to make sure that the environment variables are adjusted, so you can execute Python from the console if you need to, or from the command line. Same thing with pip. If you want to install the libraries, it should be, I mean, the path to pip has to be on in the environment variables. And I can show exactly how that's done if it's necessary. And then for installing the BeautifulSoup, you can run this command in the command line. pip3 install bs4, and we will also need OpenPyXL to export the data into an Excel sheet, and it's the same way. pip3 install OpenPyXL, and it should be done. All right, I will proceed. If I'm going too fast, you can stop me. It's okay. Okay, so we will do a quick review right now. We will see four important concepts in Python. So the 3 objects and plus functions. So the string and list and dictionary, and the different functionalities, and then how to write a function in Python. These are the main things we will need to write our code. All right, so I will simply run this from the command line, but you can run the Python IDLE, so and do the same from the console. That also works. So in order to go into the Python console, I simply have to type Python. If you're using the IDLE, you don't have to type anything; it's already there. Okay, so a string in Python is basically a list of characters. So we can create one. Let's say we can create a string Python with double quotes, and if we print, we can see that what we have assigned to it. We can also use simple quotes. It's exactly the same thing. There's no difference. We can, for example, duplicate a string. So if I put s multiplied by 2, it prints Python. Or we can also sum strings. String, as I said, is considered as a list of characters, so we can access the list by index. So index 0 is the first character, and here we get p. We can also take a slice from the string. So if we take, let's say, from index 2 to index 4. So here, if I type 5, that's not including 5. It will go to, it will take index 2, 3, and 4, and we get THO. We can also like do a slice, but by skipping a character. So exactly the same thing, but we will skip one character. So we go 2 by 2, and yeah, it goes this way. So it skips the H. We can, for example, give the upper format of this string. So here it becomes with the capital letters, or we can simply capitalize, and it returns the string with only the first letter as a capital letter. We can also test if this string has only lowercase characters, and that's true. Now, if we test, for example, with the capitalize and then is lower, it should give us false because there's one character which is not in lowercase. If we have a value of or like a variable of a different type, let's say an integer, we can also convert it to a string. So let's say with the str, so strx should print not 4, but the character 4. But if we print x, for example, it's 4. Yeah, so there are of course lots of different functions. I will also talk about the length. So the length of a string is with len, function len, and gives us the length. Here it's 6. And the final thing which we will be using for our web scraper is format. For example, we want to. This is especially interesting with the URLs. But here I'll simply give an example. Let's say the price of this product is, and I'll write curly brackets like this, and then another curly brackets, and then I close, and then I type format, and then let's say I put 7, and then for euro. And what it's going to print is the price of this product is €7. So it replaces the brackets with the variables. Well, format has many different options, but I can show you one of them, which is we can also index the parameters. So, for example, here we can invert the order, so it would print €7 instead of €7. The next type we want to see is a list. A list is the syntax is with the square brackets. So here, for example, I'll define a list that has 4 values, which I can print. I can also access the second element with index 1. I can replace the third element with index 2, for example, with another value. If I print again, the value has been changed. The same like the things I did with the string, I can do also with list. There's slicing and printing the length of the list. If I can convert also another object into a list. In this case, for example, we can also convert a string into a list. So if I write list s, what we get is a list of the characters that compose s. So here pi, p, y, t, etc. Okay, so this is concerning a list. We have also dictionaries. So a dictionary is a Python object which is indexed with the key, so not with the number. Okay, of course we can choose the number as an index, but it's well, it's not very useful because we already have the list. But what's most interesting is that we can use, let's say we have a dictionary of people with their ages. So let's say we have Anne, who's 25 years old, and I don't know, Mark, who's 31, and Lily, for example, is okay, so 28. And close the curly brackets, and we can print this, for example. We can list the keys of this dictionary. So it lists us a dictionary keys object, which we can also iterate over. So we can run a for loop over the keys, and we have a list of these keys. We can also access the values of this dictionary, and also the items in general, which will give us a list of tuples, with the first element being the key and the second being the value. We can also access the length of the dictionary. So the next thing we have to see is the functions. So how do we define a function? Simply with the keyword def. So we can define a function in this manner. Let's say we have a function that takes a variable x. Then we have to tabulate to tell Python that basically this is the next code will come under this function. So inside this function. And let's say we want to return the double this value. So with the shift enter, and then we can get out of the function definition. And now let's say we call the function on the value 4, so it prints us 8. In Python also we can define a function that has an indeterminate number of arguments, so with the star args. And we can do something with these args, for example, for arg in args, let's say print the arg. Now, suppose we give this function these values, so however many values we want, it will print all of these one after the other. Yeah, so these are the main functionalities I wanted to show you. So if there are any questions, you can ask. If there anything is unclear or I went a bit too fast, please let me know. Yeah, and then we'll just proceed to the next part. So BeautifulSoup, it's a library which or a Python package which is used to parse HTML and XML documents. Here, for example, this is a code from Wikipedia, so the beginning of the HTML code. And as you can see here, we have the HTML tag, the head, and then the title. So Wikipedia, the free encyclopedia. And let's say we want to write a script that would print or return this title, the title of the page. So it looks like this. So we import requests. We import BeautifulSoup. We set our URL, and then we call the page using the requests library. And then we give to the BeautifulSoup the content of the page, HTML content, and specify the parser, which creates the soup object. And then in this soup object, we try to find the tag title. And then we can print the text of the title. So here the title is an object, and we access its field or its attribute text to get what is inside this title. And here on the console, we can see this. So I can show you this right now. Yeah, so this is, I believe, the code. So this is right, the URL. I can change this URL to anything else. Normally, every HTML page has a title. So
Mounir,
yep.
We can't see what you are showing.
Ah, I'm not sharing the. Okay, just a second. All right, can you see now?
Yes, perfect.
Yep. Okay, good.
Thanks.
Yeah. So like I said, it's the code I already showed you. Just one line is added here, which is the that's because we have only one title in the page, so we don't have necessarily to use the function find. We can simply access directly the attribute title of our soup object, and then the text attribute of this title. And if we run this code, so if we get the title of the page twice, we can try this on a different page. Let's see. If we check, for example, something interesting here. Yeah. For example, here, I could replace the URL, and again we get the title of this page. So this works because every HTML page, as I said, has a title, so it's not a problem. But one challenge with the web scrapers is that each page is developed in a different way. So if the page does not necessarily look the same, or it does not even have the same tags or structure as another website. So normally web scrapers are customized. So you develop a web scraper for a particular website or page to extract a certain number of data points. And if you want to get data from a different website, you have to develop a different web scraper. There might be some similarities, but mostly you have to adapt your code to the new website. Okay, so the thing we want to develop right now is a price comparison application. Okay, wait a second. Is it visible now?
Yes, perfect.
Okay, so this is a small application that scrapes the website I just showed you, so this lab store. Basically, what it does is that it takes the keyword as input, and then calls the page. Builds the URL essentially, calls the page, gets the HTML code, and then gathers all the information, all the data points that we need, and essentially exports them into an Excel sheet. So I will not run this right now because it takes a few minutes to run, but the result is basically this. So I basically run it with a keyword Lenovo laptop. Let's see. So I run it with this, okay, Lenovo laptop, and then it basically gave me this. So it a list of products with the product number, the second product number, and then the price.
We can't see the results. We only can see the code.
Okay, sorry. Moment.
No problem.
Yeah. Yeah. Is visible now?
Yeah.
Okay. Yeah. Okay. So again, this is Excel sheet which was generated by the script, and it lists different Lenovo laptops with their product number, the price, the currency, and the link where this product was listed. We can, of course, get many other data points, but that would take a long time or a relatively long time to develop. So in our case, we will simply take 2 or 3 data points and just to show how this is done, and the rest is basically the same thing on repeat. Okay, so we'll start now. Just a moment. Right. So now I have my IDE. So I can create a new file. So the first thing is we want to get our web page. So we need to import the requests. Yeah, I'll save the file somewhere. Okay. Okay. All right. So, sorry, can you see this, by the way, Michael?
Yeah.
Yeah, okay, good. Just make sure. Okay, so we'll import requests. Then we have to define our URL. So in this case, this is our URL. We can simply copy it here. And then we create a variable page, which will contain our response object. Okay, so request.get URL. So this basically returns the response and creates this page object, which can have multiple fields. The one that interests us is the content, which has the HTML code. So let's also import BeautifulSoup. So from PS4, import BeautifulSoup, and we'll create a soup object and we have to give it 2 parameters. So the page content, so page.content, and the name of the parser. So in this case, it's html.parser. So now that we have the soup object, we can, for instance, print the title as a test to see if our code works. And F5. Yeah, and it prints the title of the page, which we can find here. So if we go here, we can see the title of the page. Now, as I already mentioned, our goal So our web scraper is basically supposed to take as an input a search keyword and as an output, it should return some data points regarding this keyword. So the name of the article, some ID, for example, an article number, the price, and the currency. So first we have to inspect our website to see exactly where we can find this information. We have here some laptops listed, but what we want is something that is relevant to our keyword. Here we have a search box. So let's say, for example, we write Lenovo, for example. We can see a list of products that are relevant to our search. And now the question is, how do we get this? We have to check the source code. So if we go into the source code, so in the case of Chrome, it's right click and then you go into inspect. I think in English it's inspect code. Mozilla, I think it's something similar. Yeah, so for instance, we can check this particular title or this particular name of the product to see where is it located. And here we find that there's a table. We have a table. It's a search table, and then there are different fields of this table. So the tag tr and then td, and then inside this td there are some divs, and one of them has a link with the text we are looking for and the URL. So the other thing is, as we said, we want the name of the products, we want the price. We have the price here. So we can inspect again and see where the price is located. So again, it's in the same place, but in a different div. Yeah, so it's located here. And we have to see if we have multiple pages or not. Yeah, we have. So this is the first page. Now, if we want to scrape all the data from different pages, we have to see how we can access the different pages. So we can go, for example, to the second page. And we see here that the parameters are sent with the get. So we can, for example, use this in order to construct our query to get the search results. In this case, yeah, if this was, for example, a single page application, we would have been obliged to use the Selenium, because then we have to interact with the forms and buttons. But in this case here, we don't necessarily have to. Yeah, so this is our URL. We can basically, I think, remove these. We don't actually need to have the shop and the language. And we will try to use this pattern in order to construct our query. So this search keyword can go into a curly bracket, and the page number can also go into another curly bracket. And here we will call this a URL pattern. And what we need to do is we have to replace these with any variables that we need. So, for example, we can have a variable called page number, and let's say we give it the value 1, and then we can have a variable keyword, and in this case we can give it a static value. So later we can ask for inputs from the user, but for now let's just put it as a specific value just so we can run our program. And then using the format function, as we saw earlier, we can basically create the URL by replacing the curly brackets with their values. So in the URL pattern, format, and then in the right order, so keyword and page number. And then we can, okay, so this has to be the same. Okay, URL. We run now. Okay, so here with the Suchergebnisse, so search results. So we are on the right page. Now so this works right now. We can access different pages and send our keyword and basically get the page that we need and the HTML code of this page. Now we want to access the different values on this page. Now, if we notice here, there's a small problem, which is that some of the products, they don't have a price. And this is, if we analyze a bit, we see that it's because some of the products have multiple varieties. So we have to go into this, the page of each variety to be able to see the price. So one solution would be to not get the price from this page, from the search page, but rather to simply get the name of the product and the URL, and then we go to the other page of the product to get the price. And in this case, we have to analyze the code here. For example, the article number. This is an identifier that we will need. We can analyze where this article number is located. So it's within this tag span, embedded in a series of divs. The price, same thing. We can check where the price is located. So it's in another span tag. And if we go down, we see that there are lots of other information, lots of other characteristics of this product that we can also scrape. So in our case, because of the limited time, we will not do this, but it's we will try to get the article number and the price, and for the rest, it should be the same thing. You just have to inspect where this data point is located and the tree, and basically zoom in on that particular tag to get the data that's inside. Yeah. So as I said, we have we are now on the search page. So we don't actually want to get the title. What we want is to get the list of items, and these items are actually fields within a table. So as we saw earlier, so I can check again to show this. Yeah, so we have this Power Product name. It's within the table tag. So we will try to get all the tables first, and then within the table we will search to zoom in on our the piece of information that we are looking for. So I can create a list of tables, which how do I do this? I simply use the function find all. So find all, and then I specify the tag that I'm looking for. So find all will return a list of all the tags that with the name table. So for instance, I can print the first element to see what we get here. Yeah, so we get the first table. This is not the table we are looking for. It's some other table at the top of the code. We will, of course, need to zoom in on the right one. Now, if the structure of the code generally is identical, we don't necessarily have to inspect programmatically each one. We can simply specify the one we are looking for. So we can try, for example, the second table. Yeah, so squeeze in text. This must be our table because it has a lot of information. If we check, for example, if there is a third table on the page, yeah, we get another table. And let's see, for example, if there's some other table on the page. Yeah, so we are out of the index because there's only 3 tables or 3 table tags in this HTML code. And the second one is the one we are looking for. So we can actually, instead of like taking the tables, we can simply take the HTML code of the table that we need. And in this case, we just take the second one with index 1. So this is item HTML, so the HTML code for the table that we are looking for. And then we will inspect inside of this table. Now, what we want is to get a list of our items. As I said, it's better to take especially the URL and also the name of the product, and then inspect inside the URL for each item to get the data points that we want. So we will create an empty list of items, which we'll fill out, and we have to loop through the elements inside this table. So what can we do here? We can check the children of each table. So when we have a tag, HTML tag, any tag which is inside this tag is considered a child, and each tag has an attribute called children. So if we go for child in items HTML dot children, we can, for example, try to as a start, just to check if we are in the right location, we can, for example, print the name of the child, so the name of the tag, and we just break because there are so many, we don't have to see them all. So we'll see if this is okay. Oh yeah, item, not items. Yeah, okay, so the first child is div. So this is the first tag that we encounter when we go inside this table. Okay, so but what we are looking for is a specific tag. So we are looking for the tag tr, and then inside it tag td, and then a div, and then a link, so an a tag. So what can we do? We can iterate through these children, and we specify the name of the children that we are actually interested in. So if the child.name is tr, we will again iterate through this child. So we can call, for example, this C child, or let's call it tr child. So this makes more sense. And then we go into the children of this child. Yeah, and then we are only interested in the children with the tag name TD. So we don't want the other children. So again, we have to check. Oh, I forgot. So we have to check again if the name is the one we are looking for. And again, we want to check the inside the TD tag for its children. Now, in order to make this a little bit faster, because again, we will have to check each div, and then inside the div, we have to check if we have an A tag. Instead of using the children attribute, we will use the descendants attribute. So this is a more general attribute, which includes not only the children, but even the children of children, and so on. So tr child dot descendants, and now we can check. So td child name. Yeah, I forgot to double here because this is not an assignment. So the tag is A. And so here we will print the text inside this tag. So, okay, we'll break just to not print everything, just to check if our code runs correctly. Okay, I forgot something here.
If.
If, yeah, exactly. Okay. So we went basically through each TD tag, and we went into the A tag, and then we printed what was inside, and that's the name of the product. Now, we are not interested only in the name of the product, we are also interested in the link. So, for example, here we will have to access the attribute href. So here, this is the attribute href, which contains the link. In order to do that, we will use the syntax. This is basically similar to how we access dictionaries, because basically this is a dictionary attribute of our tag, but I shouldn't put A. This is the name of the object, is TD child. So if we run this, yeah, so same thing. We get the name of the product and then the link where we can find it. Now, if you notice at the end, we have another TD or table, which is or a table cell, which contains, or actually a list of table cells which contain the links to the pages. So we don't actually need that at this level. So we will have to basically remove this. But for now, we will just keep it. So we are not interested in printing. This was just to see what we are getting. We want to add all of them into a list of items. So we can make this list of items a list of dictionaries. So each item will be a dictionary that contains certain attributes, and we will fill each one of these attributes. So we will append to this list a dictionary which contains the product name as key, and then the actual product name as the value, and then we can just call it URL. And we basically put this here. All right. So now we basically created our list. We will create our list of items. Yeah, so nothing is printed. It's okay. So basically, we know that this these product names and links are contained within our list of dictionaries, a list of items. Now that we have our list of items, the next thing we need to do is to get the data that we are looking for from inside each URL. So what we need to do is to call once again for each product the product page, and then we have to zoom in on each of the elements that we are looking for within this page in order to get the items that we are looking for, the data points that we are looking for. So how do we do that? We have to iterate once again through this list. So this time I'll make a little change. So I'll iterate with a number. So I will not iterate with the elements of the items. So for I in range, and we have to give here the length of the item list. And what we do is for each of these items, we have to go into the page and get the elements we are looking for. Sorry, there's something in the chat. Ah, okay, I've got the FES. All right. So we will go again, as I said, through each item, same as we did before. So again, we will call the requests get function, and we will give it our URL. So this URL is going to be contained for a given item I, or with index I in the URL. So we give it this URL, and then we create a new, or let's call this item page, so it's clearer here. So item soup. Once again, we create a soup object that will contain our HTML code in a certain with a certain structure that allows us to access the fields that we want. So item page that content, and then we give it the name of the parser. All right. So as I said, what we want here is to get certain values. So we want to zoom in on these on the fields where these values are contained. So for example, if you want the article number, it's contained within this span. So what can we potentially do? We can go into, for example, get all the div tags, and then iterate inside each one of these divs. While, for example, we can restrict by the certain attributes, like for example the ID or item type, etc., to make sure that we only select the tags that we are looking for. So let's start.
Yeah, go.
All right. So let's get the list of divs. find all div. And then for div in divs, let's see, for example, which div we need here. So the one that contains this article number. So it has an ID prod. We have to check if this prod is unique. It's not repeated, I believe. Oh, no. All right. Okay, so we can restrict by the first. We have to make sure that the ID is in the list of attributes. So we zoom in on the attribute list. So we go into the attribute of div, and then we list the keys. So basically, to make sure that otherwise we will get an error. If we try to get the ID of a div that does not have an ID, we will get an error. So first we make sure that it has an ID, and then we test if the ID is not none, and then the ID is equal to prod. First, let's see if this actually runs correctly. Oh yeah, I wrote only beautiful, okay. It's taking a bit too long. Okay, so we'll try to maybe find a faster way to do this. Right. Class row. Okay, so let's try to zoom in on the children of this div. Children. Okay, moment, I have to find again this item. Yeah, all right. Okay, so we have a prod and then the class row. All right. I hope this doesn't take long, but we can, for example, simply go with the descendants. If the code is not very big, it might actually not run too slowly. For descendant and diff, okay. So if I think it's in span, right? print descendant.text, and then we break just to see if this actually runs. Yeah, okay. It still takes, yeah, there's lots of different span tags. Okay, we can restrict by the class text primary. So the name has to be span, and the class should be in the attributes. Descendants keys, and descendants no class or I think the class can also be a list, so maybe it's better to put it like this. Okay, so descendants, not descendants. Okay. All right. So this seems okay. Yeah. So now, yeah, and we have to make sure that this runs once for each item. So I have to check simply for the first item. No, we get multiple values, but it's the same value. All right. So we have to add some other restrictions to make sure that this we only get the article number once. We can restrict by the class of the previous elements. All right. So what we can do is we can call the parents of this tag. So descendant.parent dot name is a div. Make sure this good for I and yeah. So we can see that we already had some restriction just by restricting the parent tag, and we can also check here the class is left and left. So we can check that the class is an attribute of the parent. And then we can check the name of the class. And right. And the class. Okay, what's, oh yeah, need another parenthesis. Okay, what else? Oh yeah, the wrong bracket. Okay, still same repetition. All right, so we're going through each div, and then, okay, we go through each descendant of a div, of this div. Okay, something we are actually repeating multiple times. I have to check if this is repeated on the page or it's just from, okay, in a span. No, it's only once. So that means that somewhere here we are actually repeating the same thing multiple times. It's not repeated on the same page. Well, in principle, this is not a problem. We can always break after we get the item for the first time, but this does not always work. Okay. All right. So let's first, or rather, let's make sure we get the item, the article number. So we'll call this article number. We can get it an initial value here as 0. So in case it's not filled out, we will be able to identify this case. And then for the item, we'll create a new field called article number, where we will assign this value. Okay, let's run this just for the first element, just to see if this actually works, and then we will print a first element. Yeah, so the first element has this product name, the URL, and then the article number has been filled out. So if we run this iteratively through all the items, normally we should be able to get the article numbers for all these items. Okay, so since we are here just in a sort of demonstration, yeah, I will first try to get the other elements, and at the end we can, for example, run the program to see if it will work. Again, we will inspect this particular data point, and here we see we have there's another span which has this property item prop price, and this is the content. So we can either get the text or the content. Now this is maybe it's more interesting maybe to get the content because it's in a number format, whereas here the comma, so that might not be very convenient. But anyways, it depends on what exactly we want to do with this data point, and we can always reformat the data point later on. So again, we can do the same process. we can go through the tree. So we try to get, so we are already here iterating through the divs, and then we go through the descendants of the div. And again, we are looking for the span, but this time we will look for a different span. So we can perhaps copy this. And simply change the elements that here we are looking for. So we want this property item prop instead of class. So we want to make sure that item prop is in the list of attributes. And then we want to check that price is the value of item prop. And then we can inspect the parents, which is another span and has the class price. So here we will change, we'll put span, and it should have a class also, and the class is price. And in this case, we want the actual price. So the price will be the attribute content of this div. Normally, this means we should also test if content is in the list of keys. Okay, and then same thing again. We will create a new field price, which will contain the price. And as we did earlier, we will simply break on the first instance. I think this this element comes afterwards, so it should be okay. Okay, just a second. I think I have to break here as well. All right, why is it very big? Ah, I'm printing the whole, okay. Okay, so I'll just print the first element because it's the only one we are actually filling out. All right, there it is. Okay, so apparently we got the wrong data points. So we got the actual currency. I have to check this out. Ah, okay. So yeah, what happens is price also is within the item prop property of the currency. So it takes this one and simply breaks. So maybe a solution to this would be to check for this first and then check for the price. So we can duplicate this once again. And again, same thing, except this time we are looking for first for price currency. And then for the price. Okay, so that's, yeah, it has the same parents. Okay, and we will return the, and here instead of price, we will have currency, and again, same thing. We will assign the currency to it. I think it should run correctly now. Let's see. And no. See, price is price. It doesn't get to this. This one, because we are breaking, of course. All right, so now we got our first item. So the product name, the URL, the article number, and the price, and then the currency. So basically we are scraping this data point. Now we could run this for all the different items. It's just going to take some time because there are lots of items. So maybe if we print here the length, we have to see, we can see how many elements we actually have, or how many items. Oh, I printed the items, not the length of the items. Yep, so we have 90 items. So as you see, it takes a few seconds for one, so it will take multiple that by 90 to run for the rest. So we don't want to wait that long. So the next thing we can do is we can perhaps export these elements into an Excel sheet, and we do that with the OpenPy Excel module. So from OpenPy Excel, we import the workbook class, and creating a workbook is very straightforward. So we can create one WB So we construct the workbook, and then we can take a sheet from this workbook, create a sheet. So we create a sheet, and then we can access the fields, like basically we access a dictionary. If you know, like generally in a Excel sheet, you can index the elements, or the columns rather, with the, or the cells with the, so with the columns with a letter and the cells with the number. So the column A with the, on the first row, and we can assign something here. For example, we can call this product name, and so then the second column we can put article number, and then the third column, column C, let's call it price, and then currency. So here I can make a D and then E, and the last one we just put the URL. And since here we are only adding one element, well, we can as well just put the rest. It's just it's not going to be filled because we are only filling the first element. So we can iterate through the item list for I in range length of the items. So we access the I+2 row of the sheet. So the first one, which contains the product, we have to convert the number into a string. So we can access the second row, for example. Since the indexes here start from 0, we have to access the row I plus 2, and then and then we put for the item at index A, we put the name. So what did we call it? The back name. And then basically we do the same for the rest. So here, C, D, and E. And second one is the URL. No, that's not, it's the last one. Okay. And then for the rest, it's going to be article number, the price, and the currency. Now, since we didn't fill all of the elements here, as I said, it would take us a few minutes to wait for the program to fill all the data points. Then we have to first test that we have this actual field. Otherwise, we can also fill it with like empty values and simply do that. But then it's probably better to test first that we have this key in the list of keys. So we do this with the if article number is in the items or the item dictionary keys, and then the same thing for the other ones. And price, and the currency. Yep. Now that we did this, okay, now that we filled all the fields, we can save our Excel sheet. So wb.save, and then we have to give a name to it. So since we started with the keyword, we can simply use the keyword as the name, and we simply add the extension, so .xlsx. And if everything is okay, normally we should find that the script has added an Excel sheet. Yeah, so it's over. Now we check. Yeah, it has added an Excel sheet. And yeah, there. Okay. Moment. It doesn't let me. Okay, I can use a different program to open the sheets. Yeah, so there it goes. So the first element has been filled with its data points, and the other ones have not. Well, if we had actually run the program for all the elements, we would have gotten those. Now, as you see, there are some elements which should not be here. For example, this Versand. So we have to filter. We have to add some conditions on our. And here, as I said earlier, there's the next pages are also listed. These also have to be filtered out. Anyway, so essentially, we just have to take more time to zooming on all the data points that we need and filter the elements that we require, and it should be fine.
You can use CSV as well. It's not a problem. I just decided to use Excel, but yeah, you can. There's the module CSV. So import CSV, and you can also create a CSV file. Maybe it's a bit lightweight, I guess, more lightweight than Excel, but I usually use either one. Yeah. Yeah, so that's it for the demonstration. I will go next into the, okay, so the next themes. Yeah, so as you saw, the challenge here is that you have a basically not unstructured, but with an unpredictable structure. So you have a website which has an unpredictable structure, and you basically have to explore and go into different fields and see what data points you need, and maybe you even have to do some transformations and such to get the data points that you want. So the challenge with the web scraping is that each website has its own code, and you have to develop a customized solution for each website you want to scrape. The second challenge is that the websites themselves may evolve, they might keep changing. And so essentially you might build a web scraper today to scrape a particular website, and then you come back 6 months later and the web scraper doesn't work anymore. So essentially you have to keep adapting your web scraper. One possible solution to that is to build a pipeline with Jenkins, for example, and you keep testing your web scraper regularly to check if there are any changes, any data points that you can't scrape anymore, and then you can adapt your web scraper as you go. Now, this is, of course, if you want to make sure that your web scraper is always working at all times. This might be useful for price comparison websites, for example. They might, every day there are customers who come and want to compare the prices of flights, for example, and they have to make sure that they always get the correct data. Yeah, so but if you just want to do one job for one particular purpose and you gather all your data and that's it, you don't want to scrape that website again, so it's not important to keep up or to maintain your web scraper. What other themes you might be interested in? Well, some websites spare you the effort to build a web scraper. They provide an RSS feed, which is usually an XML file, and you can basically receive the XML file, and well, there's some scraping to be done, but it's much more structured, and usually you can get the data much easier this way. Yeah, some websites also offer APIs. I think Amazon and eBay, they have some public APIs you can use. Okay, question, is all websites you can do web scraping on? Well, technically, yes. Anything on that a browser can show, you can scrape, but practically there are websites that use some methods to make the scraping difficult or like challenging. I think Amazon, for example, I don't think the techniques we learned today would work on Amazon. Probably you have to use Selenium. So basically they have some measures in place to make sure that people don't easily scrape data from their website. But I think there are also APIs that run on Amazon, so you don't necessarily have to build a web scraper for that. But technically, any piece of data that your browser can show, you can scrape. There's always some way you can find in order to scrape the data. Maybe you have to look into the legal issues as well. So if you're allowed to scrape the data from there or not. But yeah, normally any website. I am not sure, to be honest. I haven't checked this, but I know that there could be legal issues. It's a possibility, but so you have to make sure that you're allowed to scrape the data from there. But normally, if they don't put any measures to prevent scraping, it's their fault. So that's if they don't want you to scrape and you just do this anyway, and you don't like use some more sophisticated hacks or something like that, it's normally it's their problem. So yeah. So another thing is you can try the ScrapePy framework. It's a framework, a Python framework, which is just for web scraping, and it's more advanced, so it makes it easier to zooming on particular data points. So you don't necessarily have to use loops, for example. It's much more powerful, but slightly the syntax is a little bit more complicated. If you want to scrape data from single page applications, well, one of the best solutions you can use is, or also like you want to send a form, receive a form, click on buttons, etc. You can use Selenium, and it's slightly it makes the scraping a little bit slower, especially if you don't use the headless mode. So if you use the headless mode, it's a little faster. But yeah, for the single page applications, you don't have another solution. Another good thing you can possibly learn is to use the regular expressions. This is useful, for example, if you want to scrape some data that has some regularity, like for example emails or phone numbers or so on. It can make things a lot easier if you can simply check the structure of this data point, and I mean, instead of zooming in on the tag or something, you can much more quickly simply gather all the emails on a page from the HTML text without having to zoom in on the tag where this email is located or something, because you may not even it might not be completely predictable. Another thing is if you're interested in data analysis. So if you want to scrape data in order to analyze them for business or academic or personal purposes, you might look into data analysis packages. There's like NumPy, for example, Pandas. Pandas has some scraping functionalities as well. I think you could scrape tables more easily with Pandas. Scikit-learn is a machine learning library, and so on. There's for data visualization, Matplotlib, Seaborn, etc. Okay, scraping is not legal, but I think you can control the permission if someone could have the permission. I am not really very sure about the legal aspect, but as far as I know, it can be, there can be, like, it's sort of a gray area in some cases, but I don't think it's outright illegal to scrape data. I mean, I don't know. Personally, I never run any legal issues with data scraping, but of course it's important to look into that, especially if you want to use this in a business context or such. Yeah. So yeah, so that's it. And if you have any further questions, yeah, there it is. And thank you for listening.